said yesterday, they contribute 35 marks each. So this topic, on average, when you say 35, it could be slightly more. It is possible that it can even go as close to 40. So it's a major topic that you have to know. Please, when you're answering questions on functions, don't be scared. Generally, the hyperbola will be there. Or if it's not there, then the exponential. Usually those two, one of them will be there. In recent years, it's the hyperbola which has been tested, right? Then the quadratic and the linear, those ones are obvious. You have to know both of them. The quadratic is compulsory. Every paper, if you check all the papers, you find a question on the quadratic function, which means you have to know it. And then you have a question on grade 12 inverse functions. That will always be there as well. Right? So this question here, g of x equals to minus 4 over x minus 1 plus 2. Right? Now, it's very important for you to know the general equation of a quadratic function. You have to memorize it. Right? The general equation is y equal to a over x. Well, let me take it to you as plus p. Okay? Plus q. Right? If the general equation is like this, your equations of your asymptote, the horizontal asymptote will be y equal to q. The vertical asymptote, it will be x equal to minus p. If the general equation is like this. If there was a minus here, then this sign here will change. Okay? If the general equation has got a plus between the x and the p, then the equation of the vertical asymptote will be x equal to minus p. If the general equation has got a minus here, then that minus disappears, it becomes x equal to p. Alright? The equation of the horizontal asymptote, it's always y equal to q. It doesn't change. But for the vertical, it can change depending on the general equation. That's one trick about the hyperbolic function. You have to know whether the general equation is the one with the plus or the one with the minus. Alright? Now, that's not complicated. Right? So the first question here says write down the equation of the asymptotes of G. When you write the equations, please, there are two. One is a vertical, the other one is a horizontal. The vertical one, you start with x equal to. The horizontal one is y equal to. So if you look at this equation now, we have got that minus 1. Now, here you need to be very careful now. If you decide, okay, like in this case, the general equation is not given. If you decide that, okay, let my general equation be this one with a plus. Remember, the other one is also y equal to a over x minus p plus q. Right? I'm going to explain the difference between the two. Right? Let's start with the first one. If your general equation is the first one, it means that since you have got x minus p there, see that x minus p, and then here you have got x minus 1, right? If you equate the two, then you have x minus 1 equal to x minus p, right? Then I'm sure you can see that the x and the x are going to cancel out. I hope you can see that there, right? So this cancels with that. Right? P, write my P. Once that happens, do you see that we're left with minus 1 on the left and on the right we have minus P, which means P is going to be what? 1. Then we check this P equal to 1, we plug it here. Okay? Remember, I'm talking about that equation. Okay, let me add something there. Okay, please don't add it on this one. You have to add it to this one, x equal to p. Remember, I'm talking about this general form. Remember, if I'm talking about that general form, then the equation of the vertical axis will be x equal to p. So you take this p value, you plug it here. So what that means is, for 5.1.1, we have an equation which is x equal to 1. That's the equation of the vertical asymptote, right? Let me prove to you that I can also get it if I consider my general equation to be this. Okay? I'm going to show you both ways because this is one of the trickiest parts with regard to the hyperbolic function. Right? So what you do the same as I did earlier. Where here we have got x minus p, but here we have got x plus what? Plus p. So if we do the calculation like this, it will be x plus p is equal to x minus 1. What am I trying to do? I'm trying to prove to you that the equation will not change. It will remain x equal to 1 for the vertical asymptote for both general equations. Then if you simplify, you can see that these two cancel. You've left with p equal to minus 1. But our general equation of the vertical asymptote for this general form is x equal to minus what? Minus p. So what that means is you take x equal to minus p. Where there is p, you put minus 1. You still come to x equal to. Right? If you practice a lot, you are going to need to be aware of this. Okay? So make sure you remember that depending on the general equation, it can be x minus p in the denominator or you can x plus p. Be aware of the equation of your asymptote. Right? It can be x equal to minus p if there is x plus p in the denominator, or x equal to p if there is x minus p in the denominator. Once you know that you are home and flat, the horizontal asymptote, it will always be y equal to p. Always. Okay, but the vertical asymptote is the tricky one. Sometimes you can get a question asking you to determine the value of p. Okay, so be aware of this. Right. Okay, I've provided you lots of information here with regard to the general equation, which you have to know. Right, so I'm done with that. Then number 2 now says determine the x-intercept of the graph. Now, finding the x-intercept, it's very simple. Or in this case here, it says intercept. So it's both the x-intercept and the y-intercept. So let's go to the next page. So this is now 5.2. Our equation is g of x equal to minus 4 over x minus 1 plus 2. Right? So let's find the y-intercept. Now, the y-intercept, we get it when x is 0. Okay? By now, I expect you to be aware that to get the y-intercept, you substitute x equal to 0, and that should not be difficult to do. Okay? You should not have an increase in heartbeat because you are supposed to find an intercept. No. Y-intercept, substitute x equal to 0. Now remember, we've just put x, we just have to put here, we'll put x equal to 0, so it will be g0 will be equal to minus 4 over 0 minus 1 plus 2. Now to simplify this, it should not be a nightmare, right? The numerator is minus 4, the denominator is now minus 1 plus 2. Remember, division starts first. Yeah, division starts first. Don't start thinking about anything else. Division starts first, based on bodies. So this will become 4 plus 2, and you get a 6. So that's the y-intercept. Okay, y is equal to 6. So we can say g0 equal to what? Equal to 6. It's the same thing. G0 equal to 6 and y equal to 6 is the same thing. Alright? So I found the y-intercept. It's not complicated. Right? And it should not cause you to be scared. Then the x-intercept, you get this when y or f of x is equal to 0. Right? In this case, it will be g of x equal to 0. Right? So where there's g of x, we put 0 there. If you do that, you get 0 equal to minus 4 over x minus 1 plus 2. Alright? Then, to carry on here, don't complicate things. Take these two. Take these two here to the left hand side. Okay? Take the 2 to the left hand side, you get minus 2 equal to minus 4 over x minus 1. The denominator of that minus 2 is a 1. Then you cross multiply. Right? You cross multiply. If you cross multiply, you get minus 2 times x minus 1 equal to minus 4. And this will give you minus 2x plus 2 equal to minus 4. Right? If you simplify this, you get minus 2x equal to minus 6. So x is going to be 3. And then you are done. It's not difficult at all. It's not. Alright? I hope you can see that this was not difficult. Alright, so let's move on to sketching. Now, since we have found the equation of the asymptotes, we have found the x and y intercepts, now it's time to sketch. Time to sketch now. Okay? Now, to sketch it, let me go to the next page. Okay, so let me bring my drawing tool here. So we have got y-intercept 6, x-intercept is 3. Okay, so let me make it. Let me calibrate now. So I can make, say this is 1, 2. You're supposed to use the ruler itself. I've got a 6, so I can make this one 2. That's 4. And then I have 6 there. And then 8 there. At the bottom, minus 2, minus 4, minus 6, minus 8. So negative 1, 2, negative 3, negative 4. Right. When you are sketching, because you also need to be ready to sketch or to interpret. That's why today I'm doing this question on sketching. Later, the homework I gave you, I'll do a question on interpretation. But I'm going to incorporate interpretation here as well. So, first thing, when you are drawing the graph of a hyperbola, you draw the asymptotes first. So we know that we have a horizontal asymptote at y equal to 2. Alright? So I'll draw my horizontal asymptote. That's the first thing that you have to do. Right? Before you do anything, y equal to 2. That's my horizontal asymptote. The vertical asymptote is x equal to 1. Okay, let me use a different color. So that's my vertical asymptote. You can label it. This will be x equal to 1. Right. Now, I want you to know something which it was not part of your question, but which you may need to know when you never know your final exam. You see this point here? It's a point of intersection of the asymptotes. It's also a point of intersection with what are called the lines of symmetry. The hyperbola has got 2 lines of symmetry, right? This is additional information now as to what was here. The lines of symmetry, they intersect at a common point with the asymptotes, which means the coordinates of this point are going to be x equal to 1 and y equal to 2, right? Okay. Then the next thing now, let's do the uh, intercepts, right? We have y equal to 6, which is here. And then we have got x equal to 2, which is here, right? Then we need to determine to know the shape of the graph, whether the 2 curves are going to be in the first quadrant or in the first and the third quadrant or the second and the fourth quadrant. The moment you draw the asymptotes, right, your quadrants are going to be between the asymptotes. Okay, you neglect the original x and y axis in terms of sketching. So if you go back here, there is a minus here. This minus is very important. The denominator x minus 1 will always be positive, but the numerator is going to become minus 4. Since the numerator is minus 4, it means when you sketch the graph, it will be in the second quadrant and the fourth quadrant because of this minus. That minus there tells you that, okay, the graph is supposed to be in the second and the fourth quadrant, right? So let's sketch. So now I know that, okay, it's going to be in the second, it will be here, so I can just draw it now, right? So it will be like this. That will be my first curve. The second curve, obviously, it will be like that. So I can draw it starting from there, and then going all the way. Okay. Okay. So you start with the asymptotes, your x-intercept, determine the shape in terms of the quadrants where the 2 curves are going to be.
Sir, is it x passing through or is it x passing through?
X is passing through x equal to 2.
How come? Because you wrote x is equal to 3.
Okay, wait. Wait. Let's try make a mistake. Okay. Thank you for that. Okay, let me indicate. So our x-intercept is here. So let me withdraw. Okay. Right. So this is not difficult. Practice on your own many times how to sketch the hyperbola. All right. And also now we have got an opportunity to watch this video of me doing it. You can watch as many times as you want. You can pause. You can even pause and then you can do something else and then come back and carry on. What a privilege. All right. So, right. So I've shown you that. Now I'm just going to add a question which is not there. Sometimes you may be asked to determine the equation of a line of symmetry with, say, a positive gradient. Now you need to know that this function has got 2 lines of symmetry, right? So I'm going to write here equations. This is extra information now, okay? Because you may encounter it in the final examination. You have to be ready to answer questions on line of symmetry. So equations of lines or axis of symmetry, right? The 2 equations, there are 2. There's one with a positive gradient, it goes that way. The other one with a negative gradient, it goes that way. So the general equation, if I use, please allow me to use this general form, this one here. If I use this one here, okay, the general equation of the line of symmetry will be, with a positive gradient, it will be y equal to x plus p plus q. Okay? The other one, it will be y equal to minus x plus p plus q. You cannot come to maths paper 1 without knowing the equations of the line of symmetry, because you may get a question on that. And you have to be ready. Your trial examination did not have the question, but it might come in your final paper. So you have to be ready. Now, we have already determined what P is, Q is very easy to identify from the equation. So you just plug in the P value, the Q value, if you get them correctly. All right? Now, sometimes you will also get a question where you may be asked to determine the y-intercept. Okay, this is just an additional question. Let's say the line of symmetry with the positive gradient has the equation y equal to x plus c. Right? Sometimes you may be asked to determine that c there. If you practice a lot, you will encounter a question like that. Either for the positive, for the one with the positive gradient or the one with the negative gradient. All you have to do, in fact, the easiest way is to substitute the values of x and y at the point of intersection of the asymptotes. Because the lines of symmetry, they pass through this point. So these coordinates, x equal to 1 and y equal to 2, they are common coordinates for the lines of symmetry and also for the asymptotes. So all you have to do is substitute 2 where there is y there, where there is x, you put 1, and you solve, you get c equal to 1. And then you are done. If you don't want to do it that way, then you go via this way. Right? Depending on the question. So for this question here, we got P equal to what? P equal to 1. So if I do it using this equation here to prove to you that C is equal to P plus Q, I hope you can see that. If you compare this C here and you compare it with this equation, we have X here, we have got X there. So it means C is going to be P plus what? Plus Q. So if C is going to be equal to P plus Q, what is P? P is what? P is 1. We calculated it here. Please don't get confused. I calculated P. It's 1. What is Q? It's what? 2. So all I'm doing is I am substituting. Wait, let's see that. I didn't make a mistake there. Something on X equal to C equal to 1. Right? And P comes over, give me 2 different answers. If I put P equal to 1, Q equal to 2, I'll get a different answer from that. Isn't P greater than 1? Okay, let's see. Maybe I'm using the incorrect general form. Oh, yeah, I'm using the incorrect general form. It's equal to minus 1 here. Please be aware that we have two general forms. I picked the P value for the top one, x minus P, instead of the bottom one, which I'm talking about, which is P equals minus 1. You understand that part? Yeah, you have to be very careful there, because that part is a little bit tricky. So we have P equal to 1 for this general form here. And we have P equal to minus 1 for this general form. For the question that I'm trying to explain to you, I'm dealing with this general form. Therefore, P must be equal to what? To minus 1. Right? So let's carry on. Thank you, Mr. Thank for that. Right, so what that means is P is minus 1 plus what? 2. So you get C equal to 1, which is the same as what I got here. So for such a question, there will be two ways of doing it. Either you use the general equation of the line of symmetry, or you can just substitute the coordinates of x and y at the point of intersection of the asymptotes. All right? This is extra information. All right, so let's carry on. Let's move on to the quadratic now. Is there anybody else with any questions? Yeah, it means for the hyperbola, I've discussed almost everything. Maybe the last thing, range and domain. Yes.
So you use what we were talking about, let's say you didn't know the asymptotes on.
Where?
Like, let's say if they gave you a question and you want to give an asymptote, you use something like that, but they gave you like the axis or something.
Okay, Asher, can you make your location a little bit easier for me to understand?
What I mean is, you see where you know C is equal to P plus Q.
Yes, yes.
So those are the coordinates, you take that in the coordinates axis.
Yes.
So let's say they never gave you the asymptotes, but they give you the coordinates of the axis or something. Use that.
Yes.
Okay.
Yeah. You need to know that if, say, they don't give you the equation of the asymptote, but they give you the coordinate of the point of intersection of the asymptotes, you need to be aware that the x value there is the same as the p. The y value is the same as the what? Remember here, I wrote this down. Be aware of this. Okay, let me indicate it to you. You see what I wrote here? Check that. If y is equal to q, x is equal to minus p. I also wrote that x is equal to p. In the general form, there's got x minus p as the denominator. So y is q, x is p. Okay? Now let's talk about the domain and range. This is an extra question for this question. The domain for this question now. Because you may also get a question asking you to write down the domain of the function. Remember, your domain is a set of all the x values, right? Now, for any hyperbola, the domain does not include the x value at the asymptote, right? So you can write this as x is an element of real numbers, but x is not equal to 1. Okay? That would be the easiest way of writing without complicating things. So what this means is x can take on any value, but x can never be what? Be 1. Right? For the range, it's the same thing. Your range is the set of the y values. Right? So your y values will never include the y value at the horizontal asymptote. So this will be y is an element of real numbers, but y is not equal to 2. And then you are done. That's more complicated.
How would you do that? Using y value.
That's the way that I would encourage you to write stuff very complicated. The other format with a union is complicated. Okay? And you can make a mistake of not putting a bracket or of putting a bracket. And that will mess your answer. So I don't want to talk about that. I don't want to complicate things. Because at this stage changing, I want to make this a little bit easy as possible. Remember, you only have almost less than 4 weeks. So let's avoid complicated things. Let's make it as simple as possible. Right? If you're asked to write the range domain, it's better you write this way. It's much better, it's easy, you don't make unnecessary silly mistakes. The moment you start including the union and then the brackets, a person will make a silly mistake where you're supposed to put a circular bracket and put a square bracket or vice versa. Then it messes the answer. This way you don't mess with the answer. Just have to remember that the value at the asymptote is not included. That's all. So just like it is the domain, x is not equal to 1, range, y is not equal to 2. Then you are done. Let's not complicate it. Right? Any question? So I've discussed everything. All right. The quadratic function. Now, with the quadratic function, right, it's very important for you to know that the quadratic function has got three general forms, right? You have what's called the turning point form, which is y equals a times x plus p squared plus q. We also have the standard form, okay, which is y equals a times y equals ax squared plus bx plus c. And the x-intercept form, which is y equals a times x minus x1 times x minus x2. You have to know all three. Before you enter your math paper, one, you have to know those three. Okay, some questions you have to switch from one to the next, right? Okay, so you need to be aware of it. So for this question, you're given the equation of the parabola in standard form. The straight line, the gradient was not given, the y-intercept was not given. Right? You're also told that CDN is parallel to the y-axis, which is very important, or it's perpendicular to the x-axis, which is very important. Right? So the first question says, determine the coordinates of C. C is this point, right? That's a turning point. Okay, C is a turning point. You know, if you can get a question like that incorrect, I would wonder why. Because there are many ways of doing it, including calculus. So I will share probably all the methods, and you can decide which one is better for you. So it's 3 marks. So 6.1. Let's start with calculus. Let's say you like calculus for that question. You see that it's talking about the turning point. At the turning point, the gradient is what? 0. So your equation of your quadratic function is f of x equal to minus x squared plus 4x plus 5. You find your derivative at that point. Minus 2x plus 4. Then you will equate that derivative to 0 because the gradient is 0. This gradient here is equal to 0. Right? So, let me carry on. Please be aware that this is method 1 that I'm doing here. Method 1. Right? So, and I think it will be the best here. I'll tell you later. Right? It will be the easiest. So, put 0 there. Right? This will be equal to minus 2x plus 4. And you get 2x equal to 4, so x will be 2. So that's the x value. Please take note, if the question says determine the coordinates, it means find the x value, also the y value. Okay? So after this now, you substitute this x equal to 2 into the original function. So this becomes f2 will be equal to minus 2 squared plus 4 times 2 plus 5. This will give you minus 4 plus 8 plus 5. So that will give you 13. 13 minus 4 will give you 9. Therefore, coordinates of C are x equal to 2, y equal to 9. Right? Please, if the question says coordinates, your final answer must have an x value and a y value, and you must write the final answer as ordered pairs. Right? So this is method 1. Okay, let me indicate it. Method 1. Okay, method 1. Now, method 2 involves completing the square. Right? Okay, let me not use that method, I'll use the third method. Method 2 is to find the value of x first, but you use x equal to minus b over 2a. Do you remember that? Right? So method 2 from grade 11, x at the turning point is equal to minus b over 2a. Okay? You remember this? Right? Then What that means is, if you look at our equation, our b is 4, a is minus 1, right? So x will be equal to minus 4 over 2 times minus 1. I'm sure you can see that the answer is coming, right? So x is what? It's 2. You substitute again into the original equation. Now, I don't need to repeat it. So I'll say here f2 is equal to 9 because I got it already in the previous question, but you have to substitute. Alright? Please allow me because I'm just going to save time. I don't want to redo what I did here. Right? I don't want to redo this step. Okay, I substituted already in the previous question, so I'm going to use the answer that I got there. Okay, the most important thing is how to get x first. Right? Therefore, C is going to be x equal to y equal to 9. So this is method 2. Method 3, you complete the square, but that could be a problem. Right? That could be a problem. So I suggest that either use method 1 or use what? Method 2. There is a fourth method where you use the x-intercepts if they are there. Okay? Right? You can use the x-intercept. Right? Maybe, let me use the x-intercept because you can easily calculate them. Right? Completing the square is slightly more complex. So let's talk about method 3. Right? We just have to find the x-intercept. So our equation is f of x equal to minus x squared plus 4x plus 5. So if I substitute f of x to 0 so that I can solve the quadratic equation in order for me to get the x-intercept, this will become x squared minus 4x minus 5 equal to 0. So I'll get x minus 5 times x plus 1 equal to 0. This will give me x equal to 4 or x equal to minus 1. I'm sure you can see that this is probably a longer method because you need to know the x-intercepts. Then, you see this x value here, it's an x value at the turning point. So I can put TP there. Right? So the x value at the turning point, if you know the x-intercept, it's equal to x1 plus x2 all over 2. Right? So all you have to do is consider the 4 as your x1 and consider the minus 1 is your x2. Right? So I say, oh, sorry, it's supposed to be minus, supposed to be 5, sorry. This is a 5. I made a mistake with the rushing. So this is a 5. Please, if you have got a question, you're more than welcome to ask. This is a 5. Right? So I'll put 5 there plus minus 1 over 2. This will give you 4 over 2. So the x value at the turning point will be equal to 2. Therefore, at C, x is 2, 1, and 9. But completing the square, I don't encourage it. So I'm not going to talk about it, but you need to know that it's a fourth method. So either use any of those three. You will never go wrong. If you master at least 2 of those 3, then you're home and dry for any question of finding the borders of the turning point. And if you see the question, you won't get scared. You know what to do, where to start. Okay? Any question? Now, if you go to the question, then let's carry on. Right. Then the next question was saying, write down the range of f. The range of f. Now, for you to determine the range, you need to know what range is. Range is the set of all the y values. So for the quadratic function, you are starting from minus infinity, which is down there. Well, this one, it has got a maximum turning point. You need to know what is the value of y here. That value of y will be your maximum value of y. The good thing is we found it. By finding the turning point, we found it. We know what y is at the turning point. It's equal to what? 90. So 9 is the maximum value of y. Therefore, when you write the range, okay, when you write the range, what can I do this question? Let me see if I have the space on the. So I'm going to try to squeeze it in. So I'll write here in a different color. 6.2. Your range will be. Now, when you're writing, there are many ways of writing. I would prefer that you write it as y is an element of real numbers, but y is less than or equal to 9. Because the 9 is the maximum. If you decide to use brackets, okay, if you decide to use brackets, then you can write it as, you can also write it as, the 9 is the maximum. The minimum is what? Minus infinity. So you can write this as y is an element, we are starting from minus infinity up to 9, but you put a square bracket because the 9 is included. Okay? That's not the only way. There's a third way of writing it. Right? Let me also write it down for you. You can also write this as minus infinity is less than y, and y is less than or equal to 9. Okay, so you can decide which way you prefer, but I prefer the first one. Okay, and following the range, you should not get scared because you saw a person saying, write down the range or domain. No, the heart you should not increase at all. You should be smiling that you saw a person like that. Right? Okay, then let's carry on now. Calculate the length of AB. The good thing is, to calculate the length of AB, you have to determine the x-intercept. I found them by using method 3. So I found those x-intercepts, which means what I did here, under method 2, I'm going to repeat it because I need to find the length, right? Although don't worry, I'm going to just repeat it quickly. Right, so 6.3 with f of x equals minus x squared plus 4x plus 5. So we substitute y equal to 0 or f of x equal to 0. Then we get that. Then from there, we end up having our standard form x squared minus 4x minus 5 equal to 0. Please never forget to equate to substitute f of x equal to 0 and to write the equation in standard form because a mark is allocated for that. The standard form of the quadratic equation. Then when you factorize this, you get x minus 5 times x plus 1 equal to 0. And then you get x equal to 5 or x equal to minus 1. What this means is x at A will be minus 1. Okay? X at B will be 5. That's what it means. Then to find the length, I'm not sure if I taught you this, but maybe I did. To find the length, I'm sure you can agree with me that AB is a horizontal distance. It's a what? It's a horizontal distance. So AB will be equal to x maximum minus x minimum. This formula is very easy when you're dealing with horizontal distance. For vertical distance, you replace the x by what? By y. For vertical distance. So your x maximum is 5 minus, this is the minus of the formula, then you put the x minimum, which is minus 1. Remember, distance is always positive. So you end up getting 5 plus 1, which gives you 6 units. So that will be the length of AB.
Yeah. So it's like giving an answer with a quadratic formula.
Don't use, why are you using a quadratic formula?
You can.
Maybe you made a mistake somewhere.
So it is a negative x squared minus. So you take out the
You see what happened here? take that out, minus 4, I took the minus x squared to the right, took the 4x to the right, took the 5 to the right, and it became this equation. So you're making a mistake somewhere, just check. Alright, so this is how we get the horizontal distance. The vertical distance, you use, okay, I have to share with you this because you never know. For vertical distance, this formula here, it will be d equal to y max minus y minimum. You don't have to use the distance formula from analytical geometry to do a question like that. Because if it's a horizontal distance, it's straightforward. If it's a vertical distance, it's straightforward. Okay? Then the next question says, determine the equation of G. Now we need to find the equation of the straight line. To find the equation of the straight line, you need what? Gradient. Okay? Now, I'm sure you are aware that the y-intercept of the quadratic of the parabola is here. And that y-intercept is equal to what? Positive 5. You can identify it by inspection. Then we found the x-intercept there at B. X is 5 there. So at B, x is 5, y is 0. At D, x is 0, y is what? 5. So it's a piece of cake, grade 9 now. Yes, you are baking grade 9. Alright? So let's get on, find the gradient. So the gradient is going to be y2 minus y1 over x2 minus x1. Let me label that question 6.4. And this is 6.4. So if I consider my y2 as this point here, so it will be 5 minus 0. 5 minus 0. Then my x2 is 0, 0 minus 5. I hope you are following me. So you get 5 divided by minus 5. You get minus 1. And common sense must tell you that the gradient of a line which slants to your left has to be negative. Okay? Common sense. You can't get a positive gradient for a line like this. It has to be negative. So I found my gradient. Now, to find the equation, it's so easy. Do you agree with me that the y-intercept of the quadratic is also the y-intercept of the straight line? Do you see that? Check this. They intersect here. So which means you don't have to calculate the y-intercept of the straight line. That value of c, you don't have to calculate it. You just get it by inspection. That's how easy it was. Okay? So your equation will be y equal to this g of x there. Okay. Just going to write this g of x. So it will be g of x is equal to, I found the gradient is minus 1. Right? Remember your equation of the straight line is y equal to mx plus c, so g of x equal to minus x plus 5. And then you have that. Because the general equation is y equal to mx plus c. C is 5, m is minus 1. Do you see that it was not that difficult? No, it wasn't. So let me deviate this. Okay, so if we found the equation, then the next question was saying, now this was on transformation. T is a point on F such that D, okay, D is this point here. D is this point. D and T are reflections of each other over the line CBN, which means our line of reflection is the line CBN, right? Now the question says, write down the coordinates of T. You know that this question is so easy. But I know that you learners, you complicate it, right? I hope you know that when you have got an object and its image, okay, the distance between the line of symmetry and the object is the same as the image and the line of symmetry. Okay, okay, in this question here, D is our object. The coordinates of D are our what? Our object. So we know the coordinates of D. X is 0, Y is what? 5. Right? Do you understand that? Then we are going to reflect point D about CBN. If you reflect point D about this line here, CBN, does the X value change? Yes. Okay, what it means is point D moves to the other side, to the right hand side of the line, so it end up being somewhere there. So does the X value change? Does the Y value change? No. No. So the question now is, what will be the value of X here? That's the question. Right? Y, remember, Y does not change, but X changes. Right? So my suggestion here is, since Y is not going to change, but the X value is going to change. Right? If you want to be aware of the distance as well. Right? Remember, from this point to this point, remember we got our X value at the line of symmetry. It was X is 2 here, Y is what? It's 9. Do you remember that? We got X equal to 2. So it means X is 2 here. But since we are going to reflect about the line CB, the distance from here to there is going to be the same as from this point to that point. So what would be the value of what? Y. Sorry, the value of X rather. 4. Would be 4. You're following that? So the coordinate of T, X will be 4, Y will be 5. You have to use your X value at the line of symmetry. That's your reference. Okay? So when you reflect, like in this case, vertically, the X value changes, but the Y value does not change. If you reflect horizontally, the X value remains the same, but the Y value changes. You have to know. Are you following that? Right. Then the next question says, the line EC is a tangent to F. Right? EC is a tangent to F. Write down the gradient of this tangent. You know, I might do this question here. I was surprised that some of you are not aware that the gradient here is what? 0. I was also surprised that you are not aware that any horizontal line has 0 gradient. So the answer here, it was so simple. M equals what? 0. That's all. So if you do not get that question right, you complicated it, but it was so easy. Right? It was so easy. And then you might have come out of the paper and say, that question was very difficult. It was so easy. Any horizontal line has 0 gradient. Any horizontal line has 0 gradient. If the line is vertical, the gradient is undefined. Alright? Then 6.6.2, determine the coordinates of E. We know that, see E here. Now, this is the point here. You need to know that the equation of EC is what? If you're asked to write down the equation of EC, what would be the equation? It's y equal to 9. The equation of EC is y equal to what? To 9. Do we know the gradient of g of x, sorry, the straight line g of x? We know. You see, it says determine the coordinates. Now, well, in my case, the way that I would do it, I would just equate y equal to 9 and g of x equal to minus x plus 5. Because they intersect here, so their x value is the same, the y value is the same. Right? So I just need to find that x value. So if I do that, you get 9 equal to minus x plus 5. And this will give you x equal to 5 minus 9. You will get negative 4. Right? Therefore, the coordinate of E, right? X is what? Minus 4. Y is 9. Then you're done. It wasn't, it was not difficult at all. Where two functions intersect, their x and y values are the same. You following them? So, to be honest with you, this question wasn't as difficult as you might have thought. Then 6.7 says determine the value of k for which y equals minus x plus k is a tangent to f. If y equal to minus x plus k is a tangent, it means the gradient of the tangent is equal to the gradient of the function at the point of contact. Right? So the gradient of this tangent is minus 1. Right? The question will be, what is the value of x at that point of contact? What is the value of y at the point of contact? So for 6.7, first thing that we have to do was find your f prime of x. Right? F prime of x will be equal to minus 2x plus 4. Find the gradient or the derivative. This expression minus 2x plus 4, it's equal to the gradient of the tangent at that point. And the gradient of the tangent is negative 1. So this will be minus 2x plus 4 equal to minus 1. Then you solve for x here. So this gives you minus 2x equal to minus 5. So x will be 5 over 2. Okay? X will be 5 over 2. Then, what is the value of what? Remember, we are solving for k here. K is a y-intercept. Okay? So let's find y. To find y, you substitute 5 over 2 into the quadratic function. So f of 5 over 2 that will be equal to minus 5 over 2 squared plus 4 times 5 over 2 plus 5. This will give you minus 25 over 4 plus 20 over 2 plus 5. Can you simplify that for me? If minus 25 over 4 plus 20 over 2 is 10 plus 5. You got what? 25 over 4. Right? Then, sorry, to find the y-intercept, you just have to substitute those two values. So where there is y, I'll put this 35 over 4. Where there is x there, I'll put the 5 over 2. Right? This will be minus 5 over 2 plus k. Then you simplify it. So you take the 5 over 2, you get 35 over 4 plus 5 over 2 is equal to 12. To simplify that, what do you get? K will be equal to what? 45 over 4. So it was not that difficult. Okay. But that's all you had to do. Sometimes you can complicate a question yourself, a question which is straightforward. Don't be scared because you saw a diagram. Don't be scared because you saw that. Sometimes you realize that if you look at the diagram carefully and the questions underneath it, the questions will be very straightforward. If you know your basics, you should be able to answer those questions. All right. Now, since you are in grade 12, you need to know that sometimes calculus can also be tested under functions. Be aware of them. Right? Like in this question here, you needed to know your equations of tangent because your paper did not test you directly under calculus about equations of tangents. Okay? It came as part of functions and graphs. Calculus there. Alright? Be aware of it. Right, let's move on to inverse function. Okay. So this question on inverse functions, you always get a question on inverse functions. Now, there are three types of functions that will be tested on inverse functions. The linear, which is very rare. The linear is very rare because it's the easiest. The exponential, that's very important. And the quadratic. So you only get either, in most cases, they will test you on inverse functions on the exponential function or the quadratic function. Alright, so here you are given the logarithmic function. The inverse of a logarithmic function is exponential. The inverse of an exponential function is logarithmic. You have to know that. So you are given the equation there, you are also given a point on the graph. And you are supposed to determine the base of the logarithm. Okay? So it was not difficult to do. All you had to do was substitute the coordinates of p. So you have h of x equal to the logarithm to base of a of x. Alright? So you substitute y equal to minus 1. Then you substitute x equal to 0.5, which is a half. Then you need to solve for x. To solve for x, you have to convert your logarithmic form to exponential form. The base of the logarithm is also the base of the exponential. So this base here becomes a to the power of minus 1. Are you following that? Huh? This minus 1 here becomes the exponent, and this a here becomes the base of the exponential. The base of the logarithm is the base of exponential and vice versa. So you're left with a half on the right. Then you needed to know how to convert a half to a base of 2. So this will be a to the power of minus 1 equal to 2 to the power of minus 1. You have to know that that's the same, right? Since the exponent here is the same, we can conclude that a will be equal to what? To 2. This is not the only way. If you want, you could also move from here. See this step here? It could also be written as 1 over a is equal to 1 over 2. The numerators are the same, therefore the denominators are equal. So a is what? Is 2. Okay. Also, you have to know that The base of the logarithm can be between 0 and 1, or it can be greater than 1. If the base is greater than 1, it means that we have an increasing function. Okay? If it's greater than 1, like in this case, the value of the base of that logarithmic function, it has to be greater than 1 because it's an increasing function. If it was a decreasing function going like that, then the base will be between 0 and 1, it will be a fraction. You have to know those basic concepts or properties of the logarithmic function. If the base, so what I'm saying is, if the base is greater than 1, then the function is increasing. Okay, when I say B here, please, I'm referring to the general form. In fact, let me not confuse you there. Let me put A. So if A was greater than 1, it should be increasing, right? If A was between 0 and 1, then it will be decreasing. Okay, so this is the first part. Do you have any question? Now, it is a very important skill for you to know how to convert the logarithmic form to exponential, also from exponential to logarithmic form. You have to practice that, right? Then, the next question says, write down the equation of the inverse of that. This is so simple, right? We now know that A is 2, so our function is h of x equal to the logarithm of x to base of 2. So when you want to convert the logarithmic form to exponential, all you have to do is replace the h of x by y. Right? Replace h of x by y. Right? Then next thing, interchange x and y in 1. So this becomes x equal to logarithm of y to base 2. Then you convert your logarithm form to exponential, so it becomes 2 to the power of x equal to y. So your answer, it says in the form y equal to, the answer of y equal to 2 to the power of x. You can even write the answer without any working out. Okay? You can even write the answer without working out. So this was easy. Then 7.3, write down the domain of the inverse now. Now, you also need to know how that function looks like. If you were to draw a sketch, it looks like this. This is how it looks like. There is the y-intercept is 1, x-intercept is 1. There is a line of symmetry there, which is the line 1 equal to x. You have to know this, right? So if I'm to write the domain here for 7.3, the domain will always be x is an element of real numbers. Because we are starting from minus infinity up to positive infinity. It was the domain of the inverse, and the inverse of the logarithmic function is exponential. Are you following? Then the next question is determine the value of x if h of x is less than or equal to minus 1. Now this one is a little bit tricky now. But the basic idea is, what are the values of x such that the y values of this function, the logarithm, are less than or equal to minus 1? Now, your minus 1 is here. This is minus 1 at p, right? So, we want to know what is the value of x there, here at this point here. Because if the, or rather, if the values of x or of h of x are negative, are less than negative 1, means we are talking about going down. So if we are going down, I'm sure you can see that the y values are getting close, the x values are getting closer and closer to 0. So all we have to do is, we need to know what is the value of x at point P. The value of x at point P is what? 0.5. Right? From this point here, going down, the y values are less than minus 1. But can x be 0? No. x can never be 0 because the y-axis is an asymptote. I hope you know this. For any logarithmic function, x can never be 0 because the y-axis is an asymptote. Therefore, our answer, this question does not require you to do any calculation. Right? The answer would be 0 is less than x, and x is, in this case, because there is an equal sign there, we put 0,5, and that would be your answer. So between 0, excluding the 0, and 0,5 included, the y values are less than -1. Well, with this question, I know it can cause lots of issues. But in a test, even if you lose this, but the other marks, at least get the other marks. Okay? Yeah, because it was out of 2. The whole question had 8 marks. So get 6 out of 8. Okay?